So in this video I'm going to talk about fluid pressure, the pressure in fluids. Firstly, what do we mean by a fluid? Well, a fluid is something that can flow. So if you've got water, for example, that is a fluid because it can flow. If you've got air can flow. Yeah, so it's a fluid. So a fluid is anything that can flow. In other words, it's a liquid or a gas. Okay, so gases and liquids are fluids. So here I've got my beaker of water. What is going to be causing the pressure at the bottom of that water? If you go to the bottom of a swimming pool, you will feel pressure. You will feel the water pushing in on your ears and basically just pushing in on you. And that's what pressure is. Okay. So what causes it? Well, have a look at the bottom here. I've got loads of little water particles. Those water particles are going to be moving around and they're going to be colliding with the wall of the beaker or the surface of the beaker. This is going to be exerting a force, and that force is going to be exerted over an area, and that is what we get. That is what a pressure is. That's what pressure is. Okay, so pressure, P, is equal to the force divided by the area. So the force exerted divided by the area that it's spread over. Okay, so let's write that in: force in newtons, area in meters squared, and we've also got pressure, which is in newtons per square meter. Okay, oh no, that's cubic meters, square meter. Okay, newtons per square meter. Sometimes as well, you can write newtons per square meter. Alternatively, you can use pascals. Yeah, if you, instead of writing newtons per square meter, you could write pascals. Both are valid units of pressure. Right, now let's talk specifically about pressure in a liquid. Okay, we're going to look specifically at liquids here, not gases. Okay, if you go to the bottom of a swimming pool, you will experience more pressure the deeper you go. Why do you think that is? Well, if you're right at the very surface of the water, then the pressure is caused by the weight of the water pushing down. So if you've got less water above you, then there is less weight pushing you down, less water weight pushing you down. Likewise, if you are lower down, then there is a lot more water above you pushing down on you. So the weight of water above you is going to be higher. So how then are we going to calculate the pressure at a certain depth in a liquid? So you can use the equation P is equal to the height of the column of liquid above you. So if you were 2 meters deep in a swimming pool, you'd use 2 meters. If you were 20 meters deep in the ocean, you'd use 20, multiplied by the Greek letter rho, which we use to represent density. Okay, that's not a P, by the way. It's like a sideways P. It's called a Greek letter rho. That's the density of the fluid the liquid that you're in. So in this case, water, which that's got a density of 1,000 kilograms per cubic meter. And then you're going to multiply it by G as well, which is the strength of gravity. Okay, so if gravity is stronger, then it's going to be pulling that weight above you down harder. So let's just summarize what these are. So P, pressure, pascals or newtons per square meter. Height in meters. Rho, which is density. So if you've got more particles per square meter, then there's going to be more particles hitting you, which is going to cause more pressure. Density is in kilograms per cubic meter, and then G, that's gravitational field strength. We've seen that before in the W equals mg equation. That's measured in newtons per kilogram. Okay. Right, so there's our equation. There we go. So you can use that to calculate the pressure at any depth in a liquid that you like, just by knowing the height that you're at, or the depth that you're at, the density of the fluid that you're in, and the gravitational field strength of whatever planet you're on. Okay, in this case, in most cases it's Earth, and you'll always be given the gravitational field strength of Earth. It's 9.8 newtons per kilogram. Right, I'll see you in the next video.